know.
All right. More word problems. We're modeling with equations to solve word problems like we did the other day. The first one is a distance, speed, and time problem, which you'll have some of those to practice tonight. What is the formula for distance, speed, and time?
D equals RT.
D equals RT.
Distance equals rate times time. VT.
Distance equals rate times time. If we manipulate this equation, and if we want to solve it for t, what does time equal? We are going to divide.
D over R.
D divided by R. And if we want to manipulate this and write it as R, what does R equal? D divided by T. So depending on what the question asks you, it might ask you for like how long something takes, or what was the rate that you traveled at, or what was the distance you traveled. You could pick any one of those three because they all come from that same equation. So if you look at the problem here, Kira drove from Thorson to Canvas. Canvas is obviously a place too, it looks like. A distance of 250 miles, so they tell us the distance. She increased her speed by 10 miles per hour for the 360-mile trip from Canvas to Wallace. And if the total trip took 11 hours, so we drove 11 hours total, and you can see the total miles there, the two different amounts. What was her speed from Thorson to Canvas?
Is this actual places?
I think so. I didn't make this problem up, I'm not going to lie. I'm not taking credit. I don't know my source. I think Miss K actually might have wrote this up. So X is what we're looking for. We're looking for what was her speed from Thorson to Canvas. So X equals speed. And I'm just going to put T to C. Thorson to Canvas. Because once we get to Canvas, we increase our speed by 10 miles per hour to get to Wallace. So a picture definitely helps with this. So imagine it being a straight line distance, which probably not, but from Thorson to Canvas to Wallace. Okay, how far is it from Thorson to Canvas? So we go 250 miles. Okay, and our speed is X miles per hour. Okay, how far is it from Canvas to Wallace?
360.
360 miles. And our speed was
X plus 10.
increased by 10, so it's X plus 10. Okay, so we can think about this a couple different ways. When I went through and thought about it, I think about it as time. You could also think about it as distance. But because they give us, we know the total distance and we know the total time. But since they tell us 11 hours, I'm going to think about this as the time from Thorson to Canvas plus the time from Canvas to Wallace is equal to the total time.
That's Joe Sargent.
So our total time is how long? 11 hours. So we know that we spent 11 hours driving total. Okay, and now if you wanted to find your time, like from Thorson to Canvas, if you look up above, time is equal to the distance divided by the rate. So since everything's in time, our total time is 11 hours. Our time from Thorson to Canvas is the distance of 250. So it's 250 miles divided by our rate. And the rate is X. So that is distance divided by rate is equal to our time. Plus, the time it takes from Canvas to Wallace is the distance of 360 divided by our rate, and the rate is X plus 10 because we don't really know what the rate is. So distance divided by rate is equal to 11. So time plus time equals 11, and we used this formula from above to write those out. And so I already heard that to solve this kind of equation, we need to find the GCF or LCD, kind of similar. So find the LCD, which is
X plus and X.
x plus 10 and x. So we're going to multiply everything in this equation times x and x plus 10 over 1. So the LCD is on top, 1 is on the bottom. So what's going to happen is it's going to cancel out all these fractions. And I think I'm going to kind of run out of room, it looks like. So when we distribute, change colors, through the first term, you can see the x's will cancel. So we're left with 250 times x plus 10. Is everyone okay if we distribute that like as we go? Yes.
I thought you could only do where you multiplied it by everything when you had like the fraction on top in the fraction. That's what we did.
Oh.
Why can we do this now?
So, since we have an equal sign, it's like fraction busting. So if we didn't have an equal sign, like if we just had the two fractions added together, then we wouldn't do this. We would just find the LCD and make them the same and then combine them. But so the question was, like when we had the fractions, like the fractions have a fraction and we were adding fractions. If you're just adding two fractions, you can't cancel the bottoms out like that. It doesn't work that way. But since we're solving, we can multiply everything by the LCD to fraction bust and cancel them out, since we have that equal sign. Good question. Is everyone okay if I distribute the 250 right away, or if we distribute that just to kind of save our time?
Go for it.
250 times x is 250x. And then 10 times 250 is 2,500. Okay, and then we distribute this LCD to the second term. So now we're going to cancel out the x plus 10 because that's on the bottom. That'll cancel with that factor. So this would be 360 times x equals 11 times all of this. And I'm not going to distribute all of that. I'm just going to write out 11x times x plus 10. I'm hoping you have a little more room. I don't know why I end up so crammed down here. Make this smaller. Okay, I'm going to do one more line down here, and I'll probably have to move because I'll run out of room. So if we distribute on the right, 11x times x is 11x squared. And then 11x times 10 is 110x equals, over here, what is that altogether? 610x plus 2,500. Okay, so to solve this one, it is a quadratic, and the x squared is not going to cancel, so we have to either do factoring or quadratic formula or one of those methods. So let's bring everything over to the right, and I'm out of room, so I have to move over, but can I zoom out? So if we move everything over to the right, and I'm coming over here, we would have 11x squared. It'd be minus 500x.
Minus 400x.
Wait, minus 500x, you said.
Oh, yeah.
Right, if you subtract the 610, 110 minus 610, and then it's minus 2,500. Right? Okay, I'm sorry, I had to move over, but subtract 610x from both sides, and subtract the 2,500 down here. So we get 0 equals 11x squared minus 500x minus 2,500. Okay, and then we can either try to factor that. It does factor. I just glanced on my notes. They do factor, or you could do quadratic formula. I think factoring would be the shortest way. Although they're pretty big numbers, but what would give us 11x squared? 11x and x. So we know it has to be 11x times x. And then numbers that would multiply to 2,500 and add up to a negative 500 when we check the inners and outers. You want to give that a whirl?
Yeah, not really.
Not really.
Come on, Jacob, lock in.
20. You could try 25 and 100. Other numbers that would work would be 5 times 5 is 25, so 50 and 50. So if we do 50 and 50, if you do minus 50 here, and you do plus 50 on the inside, I believe that works out. 11 times negative 50 is negative 550. And 50x and negative 550 add up to negative 500. So it does factor. So we take the two terms, 11x plus 50 equals 0, and x minus 50 equals 0. So what are the two answers we get? 50. And this is negative 50 over 11. And remember, what was the x value? X is the speed, right? So can speed be negative? No. So our answer is 50, and this would be miles per hour. This is kind of a mess right now, but mph. A Logan 5 on a regular day. I won't do that. So her speed from Thorson to Canvas was 50. If you want to find the speed from Canvas to Wallace, you just add 10, so that'd be 60. And that would be average speed. So I know you say back roads, but what if you go through a city and you gotta slow down? It's average speed, is what we would say. All right, shared job. Did you do these in honors algebra 2? Like if it takes you 3 hours to paint one wall, and it takes your friend 2 hours to paint one wall, how long would it take you to both? Okay, so you have done this. Those of you that took regular algebra 2, we didn't do this in algebra 2, so this will be the first time you might be seeing this, but it's not bad. So a shared job. It says because of an anticipated heavy rainstorm, the water level in a reservoir must be lowered by 1 foot. Opening spillway A lowers level by this amount in 4 hours. So spillway A, it takes 4 hours to lower it 1 foot. Okay. Opening smaller spillway B takes 6 hours to do this. It's smaller, it takes a longer time for the water to come through. How long will it take to lower the water by 1 foot if both spillways were open?
2.5 hours.
Are we guessing? I heard 5, I heard 2.5.
3.
One of you is close, but you're still not right.
2.5.
It's not 2.5.
How could it be 5? If they're both.
It's not 5. And it's not 2.5. It's neither. So let's figure it out. So we're looking for how long it would take to lower the water level by 1 foot if both spillways were open. So x equals time using both spillways. So instead of just using one or the other, let's use both. Okay, and it definitely should take less than 4, because if one of them takes 4, when you open both, it should take less than 4. It should go quicker. Now, I know there's more than one way to kind of think about these. When I talk to other math teachers, I know Mr. Merle might do it one way. It's not 2. And then Ms. Chapman does it a different way. So here's how I kind of think about it. We want to complete one job, right? We want to complete this whole thing by letting it go down 1 foot. And how long is it going to take if you're using both? It's going to take you X amount of time or X amount of hours. So using both, I'm going to call that 1 over X amount of time.
How is it 1 over?
It's one job we're completing in X hours. Okay. If you use spillway A to complete that same job, it takes you 4 hours, right? If you use spillway B, that one job takes 6. So we're adding up the two times to complete the job. It's kind of as a ratio here. So one job in 4 hours, the same job in 6 hours. we're going to find out how long does it take if you do them together. So one whole job for each separately, and then it's going to add up to equal the whole amount. So we again have an equation that is set up kind of like the last one. How do we solve this? GCF, well, LCD, GCF.
LCD, oh.
So what is the LCD for these?
24.
Smaller.
12.
12 what?
Oh, 12 hours. 24 still works.
12x.
Oh.
12x. So you take 12x
Oh.
multiplied through. So 12x times 1/4 is 3x.
Honestly, you still could use
12x times 1/6 is 2x. And then 1/x times 12x is just 12. So 3x plus 2x equals 12. So if we solve this, what do we get? 5x equals 12. So x equals 12 over 5. How long did you say?
No,
More than
it's
1 hour.
2.2.
So x is 2 2/5 hours.
2 hours and 15 minutes. No.
So what is 2/5 an hour? I'll let you guys think about that. What is 2/5 of an hour?
24 minutes. 2/5?
How'd you get 12?
24 minutes.
24, that's what I said.
Because 12 is 1/5. So 1/5 of an hour, it's 60 minutes. 1/5 has 12, so 24 minutes total. So this is 2 hours. If I can write on here, 2 hours and 24 minutes.
I would say, my guess.
So if you use both of them, it would take you 2 hours and 24 minutes versus using one could take you 4, one could take you 6.
Horseshoes and hand grenades, Jacob. Horseshoes and hand grenades.
Close enough. You said something pretty close there.
Horseshoes and hand grenades.
Okay, and then last one is a mixture problem. This is kind of similar to one we did in the homework together over there. The radiator in a car is filled with a solution of 60% antifreeze and 40% water. The manufacturer suggests that for winter driving, the mixture should be 50% antifreeze, which that doesn't really make sense because in the winter you'd think that it needs to be more. But 50% antifreeze, if the capacity of the radiator is 3.6 liters, how much coolant should be drained and replaced with water to reduce the antifreeze concentration to the recommended level of 50% for winter? So it needs to go down 10%, you're right, but that's not an amount of water. So we're looking for how much water has to be drained and replaced. So it's like we have this whole container in the vehicle. We want to drain some of it out and add in water to dilute it and make it less concentrated. So our variable is x. It's the amount of antifreeze drained and replaced. And it's replaced with water. Right, because if it's a 60-40 and you want to make it 50-50, you have to take some of that out and then add in water to make it 50% water. All right, so you could draw pictures for this. Like I know that Mr. Merle made you guys do that in Honors Number 2.
Little circles.
Little circles. Okay, so if you picture this first circle, what amount are we starting with?
60%.
Well, 60%, but what amount? Amount.
3.6.
3.6, right? So the radiator is 3.6 liters. We start with 3.6 liters. Okay, and we're looking for how much antifreeze has to be drained out. So what percent antifreeze is that 3.6? 60. So it's 0.6%. Because the 3.6 liters we start with is 60% antifreeze. Okay. We are subtracting from this, right? We're taking away. Okay, and how much are we taking away?
X.
We don't know, so we call it X. And this is also 60%. right? Because our original solution was 6% antifreeze. We're taking X amount away from that, and we're adding in the same amount, right? We're adding in X amount of liters, but when we add that in, we're replacing it with water, right? Replacing with water. What percent antifreeze is water? 0. So we're adding in a 0% solution. And in the end, how much do we have? 3.6, right? Because we're taking some away and we're replacing it with water, so we're with the same amount. And what percent is that? 50%. So we start with 60% antifreeze is 3.6. We're taking away a 60% solution. We don't know how much. We're adding in the same amount. We know that that amount we're adding is 0 because it's water. And we end with 3.6 liters, and it's 50%. So if we write the equation, 0.6 times 3.6. You got a calculator?
6. Oh wait, point 6.
No. You're at least trying to guess today, though.
Point
No.
1.
3.6 times 0.6. 2.16.
Come on.
It's 2.16. And then it's minus 0.6x. Okay, and then right here, the plus 0 times x is going to be what?
0.
0, right? 0 times x is 0. We don't really need that. So that, you could put 0x if you wanted to, but I mean, it's going to be nothing. And then 0.5 times 3.6.
1.8.
1.8, I believe, is correct. You guess enough, you get some right, James?
I know.
All right, so now
It's about
combine your x's.
accuracy, not precision.
So negative 0.6x, and we're going to get rid of anything that's not an x. So what is that? Negative 0.6x equals, it's a negative number. James, want to give it a whirl?
What are we dividing what by?
We're not dividing. 1.8 minus 2.16.
1.64. Negative 0.3. I was gonna have.
I think it's negative 0.36. And then we divide by negative 0.6.
Oh, James, you should get this now, right?
What is x in the end?
James, what is this?
Negative 2.16.
Nope,
Negative.
because that was when we... It is
Negative
0.6. Because it's 0.36 divided by 0.6
36 divided by 6.
is 0.6 liters. So what amount has to be drained and replaced with water? 0.6 liters. We drain 0.6 and we add water, that much water back in, it'll dilute it down to 0.5%.
No, you can't go